Now let's look at Asian options. Asian option to press to look at Asian options, the payoff of Asian options the payoffs are related to the average price of the stock over the history. So for an Asian call, the payoff is really max of 0 on or the average price of the stock over the history minus strike. So if you look back, you would have a S max here, but here is the S average. The payout of an Asian put option is really a max of 0 or K minus the average price over the history of this option. And here, this average price is calculated as an arithmetic average. So this actually makes it a little more difficult because strictly speaking that even you have the underlying stock following the log normal process, the average, the arithmetic average of the stock prices doesn't really follow log normal. So that's why, strictly speaking, this is actually a little difficult to evaluate, and you probably need to use a Monte Carlo simulation to do that because it's not easily this S average, the distribution of this average or the process followed by this S average is not easily found. But if you really want to have a closed form solution, you can look away this difference a little bit and try to get a distribution here. And then you can try to get yourself a closed form solution. So the way to do that is you want to force yourself to a log normal process. So although truly S average doesn't follow a log normal process, but it's actually close. So you can force just assume that S average follows a log normal process, because the actual process followed by S average, this arithmetic average, is not really that far away. So if you force it as a log normal process, it wouldn't be that bad. So it's actually not too bad. And to do that is you want to basically get it fit the first two moments. Now, if you have an average as average, then let's say you have the first two moments there, then you can use Black-Scholes formula to price. And to use Black's formula. To use Black's formula, you need a forward price and you need a variance term, which is sigma square here. Now, to do that is your forward price will be the mean of this S average. And this sigma square will be 1 over T log of M2, which is second moment, divided by M1 square. And then you get the F naught and sigma square. Then you plug in the Black's formula to price this Asian option. So use the Black's formula gives us a reasonably simple way to price Asian option, where if the stock price is following a log normal process, you don't need to know the actual distribution of the average of the stock price. All you need to know or need to worry about are the first two moments of that S average. Now, this Black's formula gives us the pricing formula for a newly initiated Asian option. Means that the price of the Asian option right at the first time that it becomes in existence. Whereas if this option has been in existence for a period of time, you can't just use this formula to price it, because you have observed a period of history of this particular stock. And that observed history is actually important, and it will influence the actual price of the Asian option. So suppose you have an Asian option that for 3 months. So at time t, which the first time that the option is in existence, then you obviously can use the Black's formula to do that. You will estimated the first 2 moments of S average, given whatever assumed process that you have for the underlying stock. You have a log normal process, so you need the mean and need the variance there. And then you calculate the first 2 moments of S average. But let's say you are 1 month into the 3 months. So there's been 1 month that has gone by. So you have 2 more months to go before the option matures. And because you have observed a stock price for 1 month, and you have to make you can no longer just use that formula right away, because you have observed an average so far. So if you denote S bar as the average stock price, realized stock price during the period of the first month in our example, which means the observed average stock price during that period from the initial time to the current time, then you can actually rewrite your Asian options payoff in a different way. So an Asian call can be rewritten as this, which is that weighted average between the observed average so far and the to be realized average over the remaining period of time. So if you look at this first term here is really the realized. At the end of the day, this is really the average for the entire term, meaning that the average for the for the 3 months that the option is to be in existence, and which is the weighted average of something that you already know, which is the average of what you have observed so far, plus for 2 months that of the stock price that you don't know, but there should exist some average price for those 2 months. And you put them together is really the entire average. So you can rewrite them in a different way. But once you have rewritten it in this way here, what's going to happen is you will see that you know that S average is equal to this, but once you've written out your payoff like this, you will find that the payoff can be rewritten as a weighted average of time, which is T2 divided by T1 plus T2, which is the entire 3 months. So here will be the 2 months in our example, and times a S star average. This is basically the average of the remaining 2 months minus this term here. you should convince yourself that this payoff function is exactly this payoff function here, just rewritten in a different way. But writing your payoff function for the option after 1 month in this equivalent way shows something, because now the option is what is basically this number of unit of a new Asian option or a new Asian call option with K star as a strike and T2 as turn to maturity. So here is still S star average, which is the to be observed average price in the remaining 2 months in our example, minus this will be the new strike, okay? Which this new strike involves the original strike K and the observed average that happened in the first month in our example. So with this, we then are able to price the option in a similar fashion using Black's formula, but with this adjustment. So number one, the strike price is adjusted like this, right? And number two, the number unit of that option is being adjusted, okay? So, but after you've done the adjustment, then you can plug in the Black's formula and again, get your new price. So this price is only true at the very beginning, the first day of that options in existence. After that, you will have to do adjustments like this, okay? And depending on what T1 is, you have a different S bar. So you have to do this adjustment after that. Now there are certain times where you will see that when you do this, you actually find there are times that K star is equal to negative value for call. So what does it really mean? This being negative? Because if a regular strike price will never be negative, right? But if you just have an expression here, if your S bar is big enough, this adjusted K star will be negative. So what does negative K star mean? Well, if K star is negative, that means S bar must be so high, which is high enough such that the Asian option will for sure be exercised. So even if you have values that of the later values are low, you will still exercise that option because the observed average was so high enough. Any smaller values that you observe later on will not really impact it. And that's usually when, the worst case for stock price later on is just drop to zero, right? So if you have a high enough observed average so far, and you have had T1 being long enough, then even after T1, for the entire period of T2, the S price is zero, you're still gonna exercise. So in that condition, the K star will be negative. And so basically, you're still gonna use this formula. This will still be the payoff. But since you can be sure that it is going to be exercised, you can basically treat this at this point, then treat this option as a forward contract. So then you can just, evaluate it as a forward contract. So similarly, you can do the same analysis for an Asian put option. So the payoff will be, if you are at some point in time T1, then you do the adjustment and calculate the adjusted value for the Asian put at the initial time when the option is just come into existence. You'll use Black's formula as well, but use the Black's formula for put. So it's very similar to what we do for the Asian call. But in this case, we just applied it to Asian put. Now, similarly, you can have a situation where the K star is less than 0, less or equal to 0, which unlike in the Asian call situation where the option is for sure to be exercised, in this case, for sure that the option would not be exercised because even if you have the prices being lower to 0, your average will for sure be greater than the strike price. So at this point, if your K star is less or equal to 0, the option price is already 0 for the Asian option. Now to price the Asian option, we need to have those M1 and M2 terms, right? So we talk about that we need this M1 and M2 so that we can have F naught and sigma square, and for the Black's formula. And later on at any time T1, we just do it, but we're still following this, but we just need to do an adjustment. So what are those M1 and M2? Well, if we calculate the arithmetic average on a continuous basis, and let's say the risk-free rate is R, dividend yield is Q, and sigma is the volatility of the underlying stock. At any point in time T, M1 is this, which is related to the realized price at T. Okay, and M2 is this here, and it's related to ST squared. However, if the arithmetic average is not calculated continuously, let's say it is calculated over a discrete period of time between little t and big T, and for m number of times, then the M1 and M2 are just the sums, and rather than this. So we have to have a whole bunch of sums. That M1 will be a whole bunch of sums that involve, each of them involves a forward price of S, and M2 will involve the square of the forward price. Okay, and then it'll give us M1 and M2, then we can use them to plug into the Black's formula as we discussed before to calculate the price and initial time, and also with adjustment at any point in time before maturity.